This is problem 100 of Neetcode 150, min cost climbing stairs. So this is super similar to the previous problem, climbing stairs. But this time, each stairs actually have a cost. So we don't necessarily want to go to the top with all the possible combinations, which is pretty much the concepts of the previous problem. This time we want to minimize the cost it will take us to reach the end. Okay, so they're going to give us an array of integer costs. All right. And at every position, it's basically going to be equal to the cost of a certain stair. And we are being told that we can start from index 0 or index 1. So, okay, this is cool. Right, they're telling us to return the minimum cost for each staircase. So now we have an example here. So we have basically 3 stairs, 1, 2, and 3, with their respective costs, 1, 2, and 3. And basically one thing that has to be mentioned is that the final stair, or that the place that we want to go, is basically outside of the array. Meaning that once you reach 3, you are not done with the problem. You have to keep going by 1. All right, so actually I will show you an example that is going to solve the problem. So one thing that we could potentially do is to have a depth first search starting from the really bottom, and we could have a depth first search initially set for the person starting at the index 0 or at the index 1. Notice that I wrote a 0 here because all the numbers here are basically the representation of the array of integer that we have in our problem. So that's basically what we have in front of us is basically the problem. So a person can jump 1 stairs at a time or 2 stairs at a time, and eventually it has to reach basically the outer bound of this array to go to this levitating platform here, shown in green. So if we do it by with our mind, like what will we do in this problem? First of all, would you intuitively go to that 20 or that 10 at first? I don't know for you, but I will personally go to that 10, and after that I will go to that 5, and then I will go to that 15, and then jump here. Right, so that total cost will be 30, and it is obviously the most well, the cheapest way in our situation. So there is one observation upon which we will build our entire solution. Just take a look at this, okay? When we are in the last 2 stairs, we can definitely jump right away to the platform. So at this point, like, it doesn't really matter whether you are at the last one um, or the previous one before the last stair. You will want to directly jump onto this place, okay? So what we will do instead is that starting from this place, right, at this 35, we know that at this 35, we are really just 1 stair away from reaching the platform. So what we want to do is we just want to increase basically or level by either 1 or by 2 to reach this platform, and we want to do this in the cheapest manner. So what we can do is that initially we're just going to set a person that last that 35 here, and we're gonna have just a pointer that will take a look at these 2 stairs. And what I'm gonna do is that I just want to increase the price at this particular place, and I want to increase it by the minimum value between that 15 and that 25. So obviously here that minimum value is 15. So I will add this basically to this value here. So that's going to be equal now to 50. All right. So I know that starting from here, if I don't look back, okay, so this is something we'll care about later in the problem. If I don't look back, I know that from here, it already cost me 35 units to go, well, to jump here. And now it will cost me at minimum 50 to reach the platform once I'm there, okay? So that's the logic. On the second round, we are gonna put our little man up there, and we will just move our cube pointers. And once again, from that 5, I want to see what is the cheapest way to the platform. And that cheapest way will obviously be um, it's going to be the minimum value between that 50 and that 15. Because if I go to that 35, I know that it will cost me like 50 extra bucks to go to the platform, right? It's going to cost me 35 here and then 15 here and then boom, platform. So that's the cheapest way. But you can actually just jump here to the platform and then just finish the problem. Meaning that from this very place, we will have a cost of 20, and that's the cheapest way um, we can have to go to the platform starting from the exact same point, right? So once I land here, I'm paying $5, then I'm paying $15, then I go to the platform. That's the cheapest way. That's how we know like what is the best way at a certain point. So like when we go to that 20, we know that if we go to that very next step, if we do one step up, we're we're gonna have to pay $20 at its cheapest to go to the platform. But if we jump by two, like that, we know we're gonna have to pay $50 at in the best situation. So once again, we're just gonna put our little stick man down and our 2 pointers down as well. So now from that 20, well, I think you guessed the concept. I will take the minimum value between that 20 and that 50, which appears to be 20. So I will write out that 20 and I will put 40 here. All right. So now we know that from, oh, apologize for that. We know that from like where it doesn't really matter at this point where we start, because what we want to know is that once we land here at this 20, we have a path to the platform that will cost us um, 40 at all. So 20 here, then we're gonna have 5, then we're gonna have 15, and then we go to the platform. We are done. All right. So I think you start to I hope you understood the concepts at this point. Um, we then know that from that platform that costs tens, the cheapest way is going to be that 20 here. So we're going to cut that 10 and we're going to write 30 because it's going to be 10 plus the cheapest way we can go starting from the bottom. Right? And there you go. And then they also say, starting from the very, well, you can start from index 0, which is here, which is the first number in the array, or you can start at index 1, which is the second number in the array. Well, now we know exactly what is the cost, or what is the cheapest cost starting from the index 0, and what is the cheapest cost starting from the index 1. So we can just return the minimum value of these. And we know that this minimum value is going to be 30, right? Because we know that from this 10, we can then go to 5 and then 15 and then the platform. And then we are done. Our little man is happy out there and he paid the cheapest price possible, right? So I, I, I will do another example just to prove that this works. So I will probably go a little bit faster though on this one, but the concept is the same. So, oh, all right, all right. So I think by now you can basically guess what we're gonna do at this 40. What is the cheapest way we have to move forward up to the platform? Well, it's going to be to go to that platform that costs 50 and then jumps to the platform. So we know that from here, we're going to have a cost of 90 because once we arrive to that platform of 40, we don't have any other choices than actually paying that 40 and then paying that 50 to go to the platform. Now we're just going to go one step down. And by the way, I hope that while I'm doing this, you can see that we are actually doing a for loop here and a reverse for loop, right? So we're not starting from the beginning of the array, we're starting from the bottom. All right, so now what is the cheapest way between paying, while going to a platform that will lead us to a cheapest path of $90 or another platform that can lead us to a path of 50? Well, it's going to be the path of 50. So we're going to add 50 to that 30, which is going to give us 80. Right, so we now know that once we reach this, we can pay $80 to go to the platform. All right, let's keep going. So from this platform that costs us 20 bucks, we can then go up by one or by two stairs. But if we go up by one stairs, we're gonna eventually pay 80 bucks, uh, well, an extra of 80 bucks to go to the platform. But if we jump two steps, we're eventually going to pay an extra of 90 bucks to go to the platform. So we know that we want to just go one step up because we're going to pay eventually less money. So we're just going to basically add that 80 to that 20. So we know that from that platform 20, the best path, the best situation is that we pay 100 bucks as its cheapest. And if we go down, well, we're gonna have the choice between a path that will either lead us to an eventual cost of 100 or a cost of 80. We're gonna choose that cheapest cost of 80. So we know that the cheapest cost that will lead us to the platform is gonna be 90. And then they also tell us basically, well, the problem asking for the, yeah, the problem is asking for the cheapest cost. So we're just gonna have to return the cheapest was the minimum value between the between the cost at the index 0 and at the index 1. Here is going to be the cost at the index 0, which is 90. So let's go ahead and code this. We have basically all the understanding to complete this problem. So we're going to have a for loop, so for I in the range of, and now we have to be careful. Okay, so cost is basically all the steps we have. So we know that for sure we want this, but we want to make sure that our eye is initially going to point at that particular place. So when we started, we were like at the at this position, which is basically index 3, and the length of this entire array is 1, 2, 3, 4, 5, 6. So we're going to be willing to subtract 3 to this, so length of cost minus 3. So now we can reach the platform of the index 3. Since we're gonna use an inverse for loop, I my bound like the bounding index, I will set it to -1, so it will allow us to go up to the index 0 starting from the last index. And I also have to put a -1 here to specify that this is a reverse array. So now what I will do is that the cost at the index I, so initially the index I, it's going to be the index 3 if we have basically six steps. So this is going to be equal to, well, no, it's not going to be equal. We will add to this the minimum between the two next values, so the two options it has to jumps. And this is actually, well, I plus 1 and I plus 2. All right, so that is that is the intro algorithm. At this point, we can simply return the minimum value between the costs at the index 0 and the cost at the index 1, and that's it. If we submit this, we see it works. Awesome. So this was a lot of this was more of a conceptual problem because the code itself, it's actually 3 lines of code. Like if I delete this, it's really just 3 lines. So it is basically just a for loop, and you're done. But the understanding the concept itself was probably the most challenging part of it. So I hope you learned from this video. Oh, and before we conclude, we didn't create any additional space, so we have a space complexity of big O of 1, and we go once through all these steps. So this is a linear operation. So the time complexity is going to be big O of n, and representing the number of stairs or the number of integer in our array. All right, so I hope you learned from this video, and I hope to see you in the next one.